Now let us practice how do we use product rule to find the derivatives. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this playlist of calculus, we'll add another very important video, and that is differentiate using product rule. Here are 5 examples to illustrate how do we differentiate using product rule. The product rule is given to you over here. If h of x is a function of product of f of x and g of x, then the derivative of h of x is derivative of f of x times g of x plus f of x times g of x derivative. Perfect. So we are going to apply this rule to find the derivative of all these functions. Let's take them one by one. Question number 1. We are given that y equals to x plus 1 times 3x minus 2 whole square. So now we'll take f of x as the first term and g of x as the second term. In that case, we can write the derivative of function as dy dx differentiating with respect to time is equal to derivative of x plus 1 times the product over the second function, which is 3x minus 2 whole square, plus the first function, which is x plus 1, times the derivative of the second function, which is 3x minus 2 whole square. So that is the rule, right? Now what is the derivative of x plus 1? It is just 1, right? Therefore, we get this as 3x minus 2 whole square. Now this term, we have x plus 1 times the derivative of 3x minus 2 whole square. So we'll apply the power rule combined with the chain rule. So it will be 2 times derivative of 3x minus 2 times the derivative of inside function, which is 3x, and that is 3. So now we can actually factor out 3x minus 2 and simplify. In that case, we get here 3x minus 2, and in this case, we get 2 times 3 is 6 times x plus 1, correct? We can further simplify the things in the other bracket, which is 3x minus 2 times 3x plus 6x will give us 9x. Let me rewrite, expand, and then we'll do it. Final, right? Let's open this. We get 6x plus 6, and that is equal to 3x minus 2 times 3x plus 6x is 9x, and minus 2 plus 6 gives us plus 4. So that becomes the final answer as a derivative of the given function. Perfect. So I hope the steps are clear. Let's take up the next question now. X minus 2 to the power of 5 times 2x cubed minus 1 whole square. This is very similar to the previous question. So we can say that the derivative of this function, I'm using a different notation now, is the derivative of the first function, which is 5 times x minus 2 to the power of 4 times the second function, which is 2x cubed minus 1 whole square, plus the first function, write it as such, which is x minus 2 to the power of 5 times the derivative of the second function, 2 times 2x cubed minus 1 to the power of 1, and now the derivative of inside function, which is 6x squared. Correct? Now see what is common between the two. So we have x minus 2 to the power of 4 common as far as numbers are concerned. Since we have 5 here, the numbers are not common at all. So let's take x minus 2 to the power of 4. And we have 2x cubed minus 1 also common. So we can write here 5 times 2x cubed minus 1. And on this side, we have 6 times 2 is 12 x squared times x minus 2 as common, right? So you can expand and simplify this now. X minus 2 to the power of 4 times 2x cubed minus 1. Open this bracket, 10x cubed minus 5 plus 12 x cubed minus 24 x squared, right? So that gives you x minus 2 to the power of 4 times 2x cubed minus 1. And here we get 10x cubed plus 12x cubed gives us 22x cubed minus 24x squared. And then in numbers, we have minus 5. So that becomes the answer of this particular question. I hope the steps are absolutely clear. Let's take up question number 3 now, where we are actually given in quotient form. So you can rewrite this expression as y equals to x plus 1, which is in the numerator, times x minus 1 to the power of minus 1, correct? So now you can apply the product rule. How do we apply the quotient rule? Let us see in this video. Equals to derivative of the first term, which is x plus 1, times the second, which is x minus 1, to the power of minus 1. So I could have written this in the denominator itself, right? Or let it write like this now. X minus 1 to the power of minus 1. Plus the derivative, the first function, which is x plus 1, times derivative of x minus 1 to the power of minus 1. Clear? Derivative of x plus 1 is 1. And here we have x minus 1 to the power of minus 1. Let's write like this. And in this case, we have plus x plus 1 times the derivative, which is minus 1 times x minus 1 to the power of minus 2, correct? Now, out of these, we can take 1 over x minus 1 whole square as common. Then we are left with x minus 1 from the first term, and the second term will be minus of x plus 1, right? So minus of x plus 1. So that gives you, in the numerator, we have x minus x. Let's write down in a different ink. We have, let me first write denominator, 1 over x minus 1 whole square. And the numerator, we have x minus x, which is 0. And minus of minus 1 gives me minus 2, right? So this is basically minus 2 over x minus 1 whole square. Makes sense? So that is how we can find the derivative of this particular function. Let's move on and take the next question, which is y equals to x times square root of 5 minus 2x, right? Now, I'll do separately to show you what is the derivative of square root 5 minus 2x, right? Let's find the derivative of square root of 5 minus 2x. So some of you will write this as d dx of 5 minus 2x to the power of half, correct? And that is equal to half times 5 minus 2x to the power of minus half, applying the power rule, half minus 1, times the derivative of minus 2x, which is minus 2. And so 2 and 2 cancel with the result. What you get here is minus of 5 minus 2x to the power of minus half, which can be written as minus 1 over 5 minus 2x square root. So I did it on the side to show you how we get this result, finding the derivative of square root of 5 minus 2x, correct? I'll use this result here now, correct? So let's find the derivative of the given function. So dy dx is equal to d dx of x times square root of 5 minus 2x plus x times the derivative of second function, which is square root of 5 minus 2x. Clear? Now derivative of x is 1. That gets multiplied by 5 minus 2x. And here, the derivative of 5 minus 2x square root is minus 1 over square root of 5 minus 2x, correct? So we'll write minus here, x over square root of 5 minus 2x. Is that clear to you? X as such and derivative of square root of 5 minus 2x is this, correct? Now to simplify, let's take a common denominator, which is square root of 5 minus 2x. So that gets multiplied here. So we get 5 minus 2x minus x. And that can be written as 5 minus 3x over square root of 5 minus 2x square root. Is that clear to you? So just to show you how we get the derivative of this function as this, I've broken down in smaller steps, right? And then taken up this derivative right here. Perfect. Now let's do the last question here. Now here we have 3 terms. So they are product of 3. How do we do this? So let me show you how the product rule can be extended, right? So when you are finding derivative with 3 terms being multiplied, we can write this as dy dx equals to, see 2 is a constant, right? So you can keep 2 or you can combine 2 with any one of these terms, right? So you can say d dx of 2x cubed, right, times the other 2 terms, which are x plus 1 times x plus 2 whole square, right? Plus, you can write the first term now, which is 2x cubed, times the derivative of the second term, which is x plus 1 times x plus 2 whole square. And then you can write the first 2 terms multiplied with the derivative of the third term. You get the idea. So that is how derivative of multiple terms can be found. You get the idea. That is how we do it, right? So let's do the first step. Derivative of 2x cubed will be 6x squared. That gets multiplied with the rest 2 terms, which are x plus 1 times x plus 2 whole square. Here we get 2x cubed, derivative being 1 times x plus 2 whole square, plus we get 2x cubed times x plus 1 times the derivative, which is 2 times x plus 2. Clear? So that is the term which you get. So I'm not simplifying it further, but you can take common factors, right, and then simplify a bit. So product of all these 3 will be a common factor, right? So you can take 2x squared times x plus 1 times x plus 2. X plus 1 is not common here, so don't take x plus 1, right? Times x plus 2, right? And in the bracket, we get 3 x plus 1 times x plus 2 from the first term. 2x cube is already common, so plus we get x plus 2 times, that is it, right? Plus here we have 2 common, 2x cube we have taken out, so 2 times x plus 1 as a common factor. You can now further simplify it, but I hope you got the idea. That when you have 3 terms, in that case, find the derivative of one of them multiplied by the other 2 and repeat this process, finding derivative of each one of them one by one, correct? So I hope with this you have understood very clearly how do we find derivative using this particular product rule. Perfect. Feel free to write your comments and share your views. If you like and subscribe to my videos, that'd be great. In case you want to learn from me, you can always send an email on the address given. Thanks for your time and all the best.